Okay, we are going to solve this new problem, square of a sorted array in Python using the two-pointer technique. So as we know, the two-pointer technique is uh, we have we are going to iterate through the array using the two-pointer either from the either in the same direction or in the opposite direction. So let's go through the problem first. So we have given an integer array num sorted in non-decreasing order, return an array of the square of each number sorted in non-decreasing order. So basically, we are given uh, an array that is the input. If you see the first input in example 1 here, that is -4, -1, 0, 3, 10, and it is assorted, right? So -4 is less than -1, which is less than 0, less than 3, and 10, and they are in order. Okay, so we need to convert, we need to write an algorithm which should be converting this input into the given output. So each number will be squared and it's also assorted. So the expected output is 0, 1, 9, 16, and 100, right? So explanation, if you see after the squaring each numbers, the array becomes 16, 1, 0, 9, 100. And after sorting it, it becomes 0, 1, 9, 16, and 100. Obviously, uh, the brute force, like what you can do is you can score each number, and once you find the square of each numbers, then in the next thing you can do the sorting, right? But this is something we want to avoid, right? We want to achieve the solutions with time complexity O(n) and space complexity O(1), right? We have to do the in play in place operation. So let's see how we can achieve this. An example of this particular array, right? This is a pictorial representation of an array which has 5 elements arranged in non-decreasing order, right? -4, -3, 0, 1, 2. And we need to write an algorithm that will convert it into an array which should be 0, 1, 4, 9, and 16. Okay. Now we are going to solve this using the two pointers, and for that we need the two pointers, and we're gonna initialize the two pointer. One is the start of this array, second is end of the array. So this is my first pointer, which I will say left is pointing to, and this is my second pointer, which is right and pointing to the ends element. And we're gonna so based and in the movement rule, what we're gonna do is we're gonna loop through this array, and we're gonna compare the element at the left index with element at the right index. Just not the compare, right? We also need to compare the absolute value, right? So for example, -4 is less than 2. However, absolute value of -4 is less than, no, it's greater than modular value of 2, right? So in that case, we know that absolute value of 4 is greater than with absolute value of 2. We're gonna find the square of the value at left index and place it at the right index, right? So we're gonna find the square of this, -4 multiplied by -4, that is 16, and placing it at the second, right? Now this one, obviously, right, if we replacing the 2 with this, we are not swapping the value. We have to place this at this. So in that case, we are going to need an additional array, okay, with the same size, and we are going to fill it from the back. So as we know that absolute value of -4 is greater than 2, we're gonna find the square of the -4, which is a 16, and we're gonna place it here, right? And then my left index, I'm going to move to the next element, that is -3, which is again the absolute value of -3 is greater than 2. So square of -3 is 9. I'm gonna place it here, and my left index is moving to the 0 next element, which is again my condition will again compare the absolute values, and notice this time is the right value is higher to the left index. So I'm gonna find the square of 2, which is 4, and placing it here, and then moving the right to the next element, and then again the comparison, so that will be 1 and 0, and this is my result. So you see that the space complexity that we do need an another array, right, to hold the new elements square. So we are going to call it the the space complexity is going to be O(n), and the time complexity is also O(n) of this algorithm. Let's see how we're going to convert this into the source code. Okay, so we are going to use Python 3 to write the algorithm. So as we know, like we do need the two pointers, right? So I will call them left, which was pointing to 0, and right, which is the last element of the array. And we also need to hold the result array of the square, right? So that's gonna be, I'm gonna create an array of the same length, that will be length of nums. Yeah, so this three things is done. Then I'm going to loop, so I will call this as index, and in range I will start from right, and I will go 1 till -1, and it will be in each step will be -1. So here we were checking the values, right, from the left index with the value at the right index. So, and we also need to use the absolute values. So absolute values at nums left is greater than abs, yeah, here is greater than absolute value of nums at right. If it is true, what we're gonna do is we need to find the square, okay, which is going to be my nums left multiplied by nums left, and I'm going to move my left index to the next element. If my absolute value is less than the right index, then I will do the same for value at the right index. So right multiply by nums right, and I'm going to move right index to the next element. So that's how we find it, and at the same time, it's like once we find the the square values, right? What we're gonna put it, we're gonna add this at the index in the new array. So it's gonna be like that. And once I'm done with everything, I can simply return the result. Return result. So as you can see, what we have done here, we initialize two pointers, left and the right, and another resultant array which will be holding my squares of the uh, elements in the given array. And I am looping, I'm iterating to the nums array and checking its absolute values with at left index with the value at the right index, and finding the square, like whichever is greater, I'm finding the square and placing them from the end. Okay, so basically whichever is bigger, we're gonna place it in the end for sure. That's gonna be the largest value. Okay, and that's how it's gonna be. The why we can do that, because the given array is sorted already, so we know that the only thing comes in when there is a negative numbers, otherwise it will be a sorted number. So if the absolute value of a negative number is greater than absolute value of the right index, then surely the square will be greater. So that's it. So let's run this and see how it goes. So I'm gonna exit the screen, and you can see this is getting the correct result, right? Yeah, so just go through this technique. This is very useful technique and very efficient to solve this problems related to the array and string and linked list, and getting the result with time complexity O(n) and space complexity O(n). You can see that here we just need to define a result array which gonna hold the square values, so that's is gonna be the same length as the given array. That's all we need, and we are just completing this with the single loop. Thank you for watching.